in the meantime that our next speaker is preparing, I hope I'm sharing the right screen. So there is a second poll, so in Slido, so please answer this poll if you are interested in the topic of this time is road towards automation. And I will then invite Eetu Pilli-Sihvola from Traficom to share his screen. And now the floor is yours.
All right, thank you, Claudio. And sound check that you can all hear me. All right, so I will briefly talk today about the status of road transport automation, so where we are and what's ahead. Okay, so the talk on automation, automated driving, typically it focuses on automating the control of the vehicle so that the vehicle drives itself. And there are the development in different parts of the world. It's maybe in a bit different stages. So this is a photo from China, where you can see that there's a hand stretching out from the middle of a regular bus. And this is a profession in China called a bus shouter. So there's a person in the bus who informs people on the street that the bus is leaving from the bus stop, and in intersections when it's turning, he or she pushes his or her hand out from the window and makes a noise so people will notice that the bus is leaving or turning. So this is maybe an example of the more simple tasks that you could automate in road transport, but still when you look at the context in the transport system and the society as a whole, some things are done in certain ways to optimize it. A couple of words on the levels of automation. The typically used terminology talks about the SAE levels of automation, so from 0 to 5. And one note here when we discuss the issue today, you note that the level 3 automation is something where the driver is still expected to act as the backup to the vehicle. And when you talk about urban applications, you typically talk about level 3 type of things. When you talk about shuttles, or then maybe other things. This one I will probably skip, but I will go to the use cases here. So when we talk about urban applications for automated driving, you have the different types of shuttles. Then you have an aim towards a robotaxi type of service, and then these kind of new additions, small sized delivery vehicles, which you can use to deliver goods, packages, whatever. I think the applications for these types of vehicles is still kind of they're tried out in different things, and it remains to be seen how and when they will be used. Okay, then if you want to know where we are on automated driving on the technology front, just last week, Waymo, the company that's considered to be at the top of the technological development on automation, especially when you look at the robotaxi type of service, so level 3 in some specific area, they are opening up their driverless taxi service, so where they use regular cars fitted with Waymo technology, and it's opened now to the general public in one area of Phoenix. And in Phoenix, Waymo has been testing for 4 or 5 years, and they've had a closed test going on there, and they have been driving some tens of millions of miles in different parts of the United States, acquiring experience for their product and their technology, and now they're ready to open it up to the general public in the Chandler suburb. Okay, this was just kind of as the setup for the evaluation on where each company organization is on their maturity in developing these things. And maybe things to note are the companies among the leaders, so the upper right quadrant of assessment, and then maybe the bottom left part also is something to note when following the developments in this field. Okay, so Waymo just announced that they are opening up their taxi service, robotaxi service for the general public. So how do they see the problem of automated driving? Okay, they saw it a year or so ago as really, really hard. Ford, which was also among the leaders, they talk about how earlier there was an overestimation on how quickly autonomous vehicles will arrive. And they talk about, okay, in limited settings, in geofence settings, you can address the issue because the problem is complex. And also one of the leaders now working in another company on this issue talks about automated driving being one of the most complicated engineering problems that is trying to be solved right now. And I think this is quite fitting on where the development is. Okay, so why is it difficult? Because it's about a vehicle that moves among regular traffic, among people, bikes, other vehicles, and for full automation, it would need to be able to do all the things that a human driver does when making decisions when moving a vehicle in traffic. So it needs to sense, then it needs to think about what the situation is, what is around the vehicle. You need to do this very accurately to have a good picture of the surroundings. Then the vehicle and the system needs to be able to predict what each object around it will do next, and then it needs to plan what the vehicle needs to do itself. So do I continue on this path? Do I slow down? Do I accelerate? Do I turn a bit left, or do I turn a bit right? And it needs to do this constantly. So every tenths, hundredths of a second. And this is repeated, and this maybe kind of paints the picture. That's the part, the middle part, thinking, predicting, planning, that's kind of done via software and different types of artificial intelligence or machine learning applications, if you talk about image recognition, for example. Then the acting part is quite simple, but the B is what's difficult. And this is maybe kind of gives an inkling of why it's difficult, because, okay, to get an accurate picture of the surroundings, the vehicle and the systems, they really do need to identify all the objects that are around. So, and then they need to classify them, and then they need to predict what they'll do. So are they people, are they something that should be avoided, or is it something that you can just kind of go on? And the information you get from cameras, other sensors, it's never complete. It's always kind of the quality of the data is something, and it's not 100% at any time. And when you combine data that's of different quality, if you just look at it from a statistical point of view, you know that the kind of sum of the parts is even more inaccurate than the original data. Okay, but what's kind of coming up or being tested? I mentioned the small delivery robots that are here pictured, where kind of the use case that you could use it in an urban setting are kind of short trips, maybe a kilometer, 2, 3, not maybe in a huge metropolis, but in a kind of semi-urban, suburban area, or then a more quieter urban environment. And in general, different types of remote monitoring solutions, whether it's the shuttles that been tested in Finland and around the world for transporting people, whether it's goods delivery on a small scale, medium scale, or then the kind of full truck size scale that Einride is trying to do and accomplish. But the basic solution here is kind of an automated vehicle and then remote monitoring for it. So in problematic situations, there's a control center that can intervene and give guidance to the vehicle. Not so much as having active remote control, so someone constantly driving the vehicle remotely. This is not something that's currently seen as really that feasible. So the vehicle will have to be able to navigate on its own and kind of get along on its own for the most part, and then in problematic situations, the control center could intervene. And Einride just published their kind of pricing scheme for the vehicle on the bottom right, which is kind of a tractor-sized solutions. They have a kind of $10,000 reservation fee and then around $20,000 monthly service fee. So they also going for a service type of pricing for one vehicle that could operate 20 hours per day, but then you get the control center service as part of the package. So you don't buy the vehicle, but you buy the service of the vehicle transporting the goods. How this works out in practice is still kind of remains to be seen, but it's also kind of a novel approach to using the technology to solve a problem. Okay, the robotaxi type solution. So kind of what's also on the Slido poll, the question of when do you think you will be able to use a robotaxi type service in your home city? And one ride-sharing company, Lyft, kind of opened up their logic on how they could use it. Here, the city example is San Francisco, but you kind of you can get a feasible implementation if you limit the areas and the routes that the vehicles will operate. So kind of limiting the operational design domain of the vehicle. So you need to be specific on where to use the vehicle. So choose roads that have low speeds, that don't have bike lanes, because intersections with bikes are still difficult and they're dangerous, kind of the speed difference, and it's hard to detect bikes using the current sensor suites. Then difficult intersections, if you have left turns across oncoming traffic, these are the ones that you should eliminate if possible. And then you would have the routes that the ride-sharing service or the taxi service could operate. And then it would mean from a user standpoint that if you order the vehicle and it's the kind of robotaxi type, then you might not get it right where you want. So you might need to walk a block or two, but in most cases that would not be the issue. At least this is the thinking behind the Lyft case. Okay, and they kind of also opening the business logic on if you don't have the driver there, because in right now, whether it's Uber, Lyft, or other ride-sharing taxi services, the driver is responsible for the costs of the vehicle, and the company just pays commission to the driver. Okay, if you don't have the driver, there's no owner of the vehicle except the ride-sharing company. So the whole setup changes. Then the company would own the fleet, and they need to manage the fleet. Now they don't do any fleet management because the drivers use their own vehicles. So the kind of situation changes quite a lot. Okay, so how does the future look in current estimates? So this is from the last year, from the AirTrack Automated Transport Roadmap. And this is the estimated development path and market introduction for urban mobility vehicles. So shuttle types or city buses or coaches that would be level 4 automation. So they would work on some routes in some areas in some conditions. And it's kind of the window was quite large last year. So from that year to, or from 2018 when the first products were on the market, to 2030 which is 10 years from now. And this is something, there's no specific estimate on what's that. Then if you talk about what's important when moving forward with automation, trying to get the benefits from it, not kind of looking at it as a goal in itself. Last week, the Finnish Ministry of Transport and Communications hosted a high-level meeting on connected and automated driving, where the three main pillars of development are kind of human centricity, enhanced data sharing, and working on the regulatory framework. And kind of taking the needs of humans and people who move around as the starting point in advancing different solutions. What are things that work for people, that work for cities? And also working on the transparency of the technology so that people understand how the technology works, they understand what it does, what it doesn't do, and also addressing then issues related to data sharing, both kind of between countries on experiences gained, and then working on acceptance of new technology, not forgetting the importance of advancing the regulatory framework. It's often stated that the kind of regulation is or has been the barrier for trying out automation, but developments on this front have actually been quite quick. And also when it relates to the international conventions on road traffic, which are the agreements that state the basic principles that then each nation implements in their own national legislation. And the international framework is already strongly moving in the direction where an automated driving system can for some time take on the role of the human driver. So the kind of the regulatory framework is moving, and new systems, when they're developed, they're examined in the UNECE, and kind of requirements for testing them and validating them are being worked on. Okay, this is maybe too specific one. Then a topic relates to automation and connectivity is kind of the role of the vehicle as a sensor, which will be much more important in the future. So getting data on congestion, on traffic conditions, accidents, weather, road conditions, whether it's automatic or user-generated information. This is something that in Europe, especially, a lot of work is being done, and the vehicle fleets in countries are every year more and more able to send and receive information from other vehicles or from traffic management systems. And this is also, you can, in the future, the view is that you have new tools for traffic management and for traffic information services, and you can also have better data to use in maintenance planning tasks. But then you need to address the varying levels of quality and different formats for the data. So a lot of work needs to be done there as well. Okay, this may be a bit specific, but what does the current state mean for the future? And the impacts of automated driving, it's at this point a bit hard to quantify because it impacts on everything, on mobility, safety, efficiency, emissions, and land use, but it depends on which way the development takes. So will it focus on kind of improving individual mobility, which could lead more vehicles, more vehicle miles traveled, and more emissions? Or will the future look more like using automation as part of public shared transport, where you have then improved mobility options, better accessibility, also for new user groups, land use, you need less space for parking, less emissions and more efficient transport system. But the things that can be said quite certainly right now, a lot is unsure, but you can say that there will be challenges on kind of people using the technology, whether it's in their personal cars or otherwise, or interacting with automated vehicles at some point in traffic, because the systems are different, they have different limitations. So it's really important to increase the people's understanding and awareness of what systems are, what they do, and to be transparent about how the systems make decisions about moving among traffic and people. And then if you talk about where to invest, it would be at this point wise to identify measures, so-called kind of no regret measures, that you should do regardless of what the pace of automation will be. So that will benefit some other aspect in any case. So whether it's related to improving infrastructure, physical infrastructure or digital infrastructure, or the data quality, these are the things that should be prioritized right now, as it's too difficult to say for sure what the pace or future will be. Of course, having a kind of a digital traffic environment, we need to have traffic rules in digital form in the future. We need to have information about the traffic equipment, road markings, everything that you have, the kind of metadata on the traffic network, traffic infrastructure, and cities as well, urban infrastructure. And of course, it requires some agility also from the regulatory point of view. And I think from this point, it looks pretty good also on the international front. We need to tolerate a bit of uncertainty going forward, and we want to avoid this kind of future where things are kind of sold on false pretenses, or just by creating misunderstanding among users, so that if something's called one thing, it doesn't mean that it always does the things that you would expect it to do. So this speaks to increasing people's awareness of what the technology does, what it doesn't do, and kind of being open about the challenges that are still present. Thanks.
Okay, thank you very much, Eetu, for the very interesting presentation. I think we can again accommodate one quick question now and then leave the others for the next panel session. There is actually one practical question, let's say, where you were mentioning these small delivery robots. So the question is, what kind of infrastructure do we need for operating these robots in the future? So the person asking the question mentioned that neither sidewalks nor streets seem suitable, and on bike lanes they might be an obstacle for those kind of new robots.
Yeah, I think that's a very valid question. So the kind of current implementations run on sidewalks or areas where pedestrians would walk, because the speeds are comparable to pedestrians, so kind of 4, 5, 6 kilometers an hour. But this is, again, we don't know if this is the final form factor for the vehicle. So if at some point they might be kind of urban speeds but small size, when they would be a vehicle class of their own. So then they could kind of drive among regular traffic. But it's a question that there's no, I don't think there's a good answer, but it's a good point to raise, because it's not, if you get a huge number of these type of robots going on among pedestrians, and especially among bike traffic, and they're very low profile, not necessarily easy to spot, even though they have the flag up to kind of show that something's moving. Yeah, it's a very, very important question.
Okay, thank you very much. Again, I think it's better that we swap to the next speaker.